Sketch the approximation to the definite integral going from a to b of x d of x, and determine if that estimation is over or under estimation. And we want estimation of right of 2, left of 2, trap of 2, and then mid of 2. Remember, the definite integral going from a to b of x d of x represent the area under the curve of the curve is above the x-axis, and in case of the curve is below the x-axis, then it means the area above the curve. And also notice here this 2 in here. That means in the estimation, we're going to present that estimation by 2 sub-intervals. And then we have this graph and with this graph. First, let's go ahead and do number 1. Notice these are 5 graphs of the same graph of number 1. So we're going to present first right of 2, and then left of 2, and then trap of 2, and then mid of 2. However, there are 2 ways to present mid of 2. So this is the second way. First, let's move to do the right of 2. So for that, we're going to present it by the right-hand sum. Notice here this 2, that means we're going to present the area under the curve by 2 rectangles. And then since this is right, that means we're going to start growing our rectangles going from the right to the left. So first, I'm going to note half of the interval, which is in here, and then I'm going to draw 2 rectangles. So the first rectangle going to be from B until I hit the curve, and then I'm going to move to the midpoint. That's the first rectangle. Now I'm going to draw the second rectangle until I hit the curve, and then I'm going to move to the left. And these are 2 rectangles. And remember, we start drawing these rectangles from the right, therefore this is the right-hand sum. Now notice this area above the curve. This area is our estimation. However, the curve, it's only this one here, and this area is above the curve. So we are including more area than the actual area under the curve. Therefore, this is considered to be overestimation. Now we're gonna do the left of 2. So for this case, first, also we're gonna present this area by 2 rectangles, and then we're gonna do the left-hand sum. So we're gonna start from the left and then going to the right. The first step is to note where is the middle of our interval, which is this point in here. Now let's start drawing our rectangle. So again, I'm gonna start from the left. So I'm gonna start from A until I have the curve, and then I'm gonna move to the right, the midpoint. And then I'm gonna draw the second rectangle that's gonna be from the second point in here until I hit the curve, and then I'm gonna move to the point B. So here we have 2 rectangles, and we start drawing this rectangle from the left. So remember, we are estimating the area under the curve in here. However, when we draw these rectangles in here, this area is missing. We are not including this area in our estimation. Therefore, left of 2 gonna be under estimation. Now let's move to trap of 2. That means trapezoid of 2. So we want to present the area under the curve by 2 trapezoids. So first, again, we have a trap of 2. So we will have 2 sub-intervals to estimate the area. So the first step is to locate the midpoint in the interval, which is in here. Now I'm going to draw these lines first. So going from A to the curve, and then going from the midpoint to the curve, and then going from B to the curve. And then I'm going to connect these points by a straight line. Now, if we zoom into the estimation using trapezoid, you can see that we are including more area that above the curve. Therefore, trap of 2 is considered to be overestimation. Now let's draw the mid estimation. So the first step is to point where is the midpoint in the interval, which is in here. And then to draw the mid, here remember we're going to present that by 2 sub-intervals. However, since it's a mid, it means the middle point in one rectangle. So here, this is going to be one rectangle here. So therefore, we're going to start drawing the rectangle from this midpoint. So I'm going to take that midpoint until I hit the curve. And then to here, I'm going to draw a straight line, and then we will have the first rectangle. And then for the second rectangle in here, I'm going to go to the midpoint in here, and then I'm gonna go until I hit the curve, and then I'm gonna draw a straight line, and then I'm gonna connect it. And that should be the second rectangle. So remember again, 2 means 2 sub-interval, which we have in here. However, mid means the mid of each of the rectangles. Now let's draw the mid of 2 in another way. First, I'm gonna mark our midpoint in the interval, and then again, this is the same step. So I'm gonna go to the midpoint in the first rectangle until I hit the curve, and then I'm gonna draw a tangent line to that. So the tangent line gonna be the curve, and then I'm gonna connect that. So going from A to that tangent line, and then going from the midpoint to that tangent line. Now we're gonna repeat the same steps to draw the second rectangle. So first I'm gonna point the midpoint in the rectangle, then until I hit the curve, and then I'm gonna draw a tangent line to the curve at that point. And then I'm gonna connect both sides. These should be one line in here. Now notice these are the two ways to present the mid of 2. However, from this way here, if you zoom on the graph, you may notice if this is over or under estimation. Here, if you zoom in on the graph, you may notice this is an under estimation, since we are not including these areas under the curve. And also remember that when the right is overestimation, then the left gonna be underestimation for the same graph. And the same thing apply for trap and mid of 2. So if the trap of 2 is overestimation, then mid of 2 gonna be underestimation. So this is just a way to check your solution. Notice this is the graph of the second function in here. Notice that I repeated that graph 5 times for the estimation of right of 2, left of 2, trap of 2, mid of 2, and then there's 2 ways to present the mid of 2. That's why we have this graph in here. Now let's go to right of 2. Notice that the curve of the second function is below the x-axis. Therefore, our estimation gonna be above the curve in this area in here. Again, to draw right of 2, first we're gonna mark our midpoint in the interval, which is in here. So we're gonna start drawing the rectangles from the right. So I'm gonna start drawing the rectangle starting from B until I hit the curve, and then I'm gonna move to the midpoint. And then I'm gonna go from the midpoint in here until I hit the curve, and then I'm gonna move to the left until A. And here, notice that we have 2 rectangles, and start drawing these rectangles from the right. Now, note that the area above the curve gonna be the whole area in here. However, we are not including this area here in our estimation. Therefore, this estimation is overestimation, because the area here is less negative than the area under the curve. Or you can think about it also as the opposite way when the area is above the x-axis. So for example here, you may notice that this area not included, so you may think this is underestimation, but since the graph is negative, then you flip that, so you say this is overestimation. Now let's draw left of 2. So the first step, I'm gonna mark our midpoint, and then I'm gonna try drawing this rectangle going from the left. So I'm gonna start from A until I hit the curve, and then I'm gonna move to the right until the midpoint in here. And then I'm gonna go from the midpoint in here until I hit the curve, and then I'm gonna go to the right to the point B. And here we have 2 rectangles. And in here, this is the area under the curve in here. However, we are including this more area in here. Notice this area is more negative. Therefore, this estimation is underestimation because we are including more negative area than the actual graph in here. Or you may see that this area is more than the curve, and you may think this is overestimation, but then this is the graph is under the curve, therefore it's underestimation. So you choose the opposite. Now let's move to trap of 2. Again, the first is to mark our midpoint in the interval. Then I'm gonna start drawing straight lines going from A until I hit the curve, and then from the midpoint until I hit the curve, and then from B until I hit the curve. And then I'm going to connect these points by a straight line. Now when you zoom in for this area in here, you notice that there's a space in here between the estimation and between the curve. Therefore, this is overestimation since the area is negative and we are including less negative area. Now let's move to draw mid of 2. This is the first way, so I'm gonna mark the midpoint in the interval. And remember, mid of 2, so mid means I'm gonna go to the rectangle and then I'm gonna choose the midpoint in the rectangle. So this is the first point in the rectangle. I'm gonna go there and then until I hit the curve, and then I'm gonna draw a straight line in here. And then from straight line, I'm gonna connect it. And then I'm gonna do the same thing for the second rectangle. I'm gonna mark the midpoint in the second rectangle until I hit the curve in here, and then I'm gonna draw a straight line, and then I'm gonna connect that line. That's mid of 2. Now let's move to the second way to draw mid of 2. And from this way, we can notice is this over or under estimation. So I'm gonna mark our midpoint in the interval first, and then I'm gonna do the same thing that I did for the first mid of 2. I'm gonna go first rectangle, and then I'm gonna mark the midpoint in there, and then the same thing for the second rectangle. Now for each point, I'm gonna draw the tangent line to the curve. So the tangent line this here gonna be like that, and then the tangent line to here is gonna be like this. So now what I'm trying to do is to connect this tangent line. So from here we have this point, and then we have this point in here. Then for the second rectangle we have this point in here. Now notice that the area above the curve is this area in here. However, we're including more area, or since the graph is below the x-axis, since it's negative, we are including more negative area. Therefore, this is considered to be an underestimation. Also notice that when the right is overestimation, the left is underestimation for the same graph, and then if the trap is overestimation, then the mid gonna be underestimation. This is just a way to check your solution.